filter. So it will be continuous. So next time, okay, quickly, okay. Let F be continuous on the closed interval AB, and definable on the open interval AB, okay? On the open interval AB. If FA equal to 0 and FB equal to 0, then there exists at least one point C such that F prime C equal to 0, okay? F prime C equal to 0. This is the law system. And then we introduce another system, means the mean value system. The mean value system means that let F be continuous on the closed interval. On the closed interval AB. And definable on the open interval. On the open interval. On the open interval AB. Then okay, then there is at least one point C belongs to the open interval AB, okay, the open interval AB such that F prime C equal to FB minus FA divided by B minus A, okay? So this the first is the law system, the second is the mean value system. We prove it. And now this class we introduce another result, okay? The result means that the constant difference. The difference system. The constant difference system. Okay. For this function, for example, okay, if we know a function f prime equal to g prime, okay. If for two functions, these two functions, they have the same derivative on an open interval, okay? On an open interval. For any x belongs to the open interval AB, we have f prime equal to g prime, okay? This means if two functions have the same derivative, okay, on the open interval, so what's the relationship between f and g? What's the relationship between f and g? So actually for this, okay, actually we have what? We have actually for this function we have the fx minus gx equal to some constancy, okay? Some constancy for any x belongs to AB. So here means that if two functions, okay, have the same derivative on the open interval, then one function can be expressed by another function plus a constant, okay? Plus a constant. Actually, for this is the condition, okay? This is the result. We can use the mean value system to prove this result, okay? To prove this result. Actually, here it's easy, okay? Give any x1, x2, these 2 points, okay? These 2 points belongs to AB, belongs to the open interval AB. And we let x1 less than x2, okay? So now we see the function. Now we see the another function, okay? We choose 2 points, x1, x2, okay? 2 points, x1, x2. This point is any point, any 2 points, such that x1 less than x2, okay? That's x1 less than x2. So now we see this function fx, hx, okay? We define a new function hx. Hx is the difference of f and g. So we define a new function h. This function, okay, this function defined by f minus g, okay. We see this function on this interval, on the closed interval x1 minus x2, okay, x1 minus x2. We see this function on this interval, okay, on this interval. So we can see first here, this function fx and gx. Fx is definable on this open interval, yeah? So here means what? Here means f, of course, is continuous on this open interval. F is continuous on this open interval, so of course fx is continuous on this closed interval. Gx, okay, Gx is definable on this open interval. So here means Gx is continuous on this open interval, okay? Continuous on this open interval, so of course Gx is continuous on this closed interval. So fx continuous, Gx continuous, so the difference hx is continuous on this closed interval. Okay, so here since fx, Gx is definable. Since fx and gx are definable on the open interval AB, so we know if a function is definable, then the function is continuous. Yes. So we have fx, gx is continuous. continuous on the open interval AB, yeah, on the open interval AB. And now we know that x1, x2 belongs to the open interval AB. So of course, this is A, this is B, yeah. So x1 is here, x1 is here, x2 is here, yeah. So of course, fx, gx is continuous on the open interval. So of course, the fx, gx is continuous on this closed interval, yeah. So we have what? So we have is also. So we have and also continuous. Also continuous to close the interval x1, x2. On the closed interval x1, x2. So here we have what? So we have hx, because hx is the difference of f minus g. So f continuous, g continuous, so hx is continuous. Yeah, it's continuous on x1, x2. Continuous. fx, yeah, fx is hx is continuous on the closed interval. Of course, hx is also definable, yeah, because fx, gx is definable. So since fx, gx are definable, since fx, gx are definable on the open interval AB, so we have hx is also definable, okay, it's also definable. It's also definable on the closed interval x1, x2. Yeah? So this means that hx, this function is continuous on the closed interval and definable on the open interval and definable on the open interval x1, x2. Yeah? So we can use the mean value system. Yeah? So by the mean value system, we have what? So by the mean value system, there is at least one point. At least one point C belongs to AB, such that F prime C equal H prime C, okay? H prime C equal to hx2 minus hx1 divided x2 minus x1, yeah? So this is the mean value system, yeah? So here now we can see here h prime equal to what? H prime C actually equal to F prime C. Here actually equal to F prime C minus G prime C, yeah? So here now we can see F prime C equal to G prime, yeah? For any x belongs to AB. So here means what? Here means they are the same, yeah? So the difference equal to 0, yeah? So the difference equal to 0 here means what? Here means the denominator, yeah, the numerator equal to 0, yeah. So from here we have hx2 minus hx1 equal to 0, yeah. hx2 minus hx1 equal to 0. So here means what? So here means hx1 equal to hx2. Yeah? hx1 is what? I'm sorry, here I made a mistake. Here actually we consider what? We consider h prime, okay? H prime equal to 0, h prime equal to 0, h prime equal to 0, so by the, we know, by the solution here, page 257, okay? 257, solution 5.1.2, okay? 5.1.2. Number C, okay? Number C. If f prime equal to 0 for any value of x in AB, then f is constant on AB, okay? So here means what? Here means f prime or h prime equal to 0, yeah? So here means h prime, okay? H prime equal to 0. H prime equal to 0 for any x. For any x belongs to AB. For any x belongs to AB. So here means hx is a constant. Hx is a constant on AB, okay? Is a constant on AB. So here means what? hx is fx minus gx equal to c. Yeah, equal to c. So here means what? Here means f can be expressed by gx plus c. Okay, plus c. So I'm sorry, I made a mistake here. So because the new function, okay, the new function is the difference of f and g, between f and g. So h prime equal to 0, h prime equal to 0. So we have h equal to a constant, okay? H equal to a constant. Now this is the constant difference cylinder, okay? The constant difference cylinder. So now we give an example. To prove arc sin x plus arc cosine x equal to 1/2 pi when x belongs to -1 to 1. Okay, -1 to 1. So here, to prove arc sin plus arc cosine equal to 1/2 pi. Okay, x belongs to minus 1 to 1. Okay. So here, actually, we can see the left hand side. Okay, the left hand side actually is a function. The right is 1/2 pi. Okay, 1/2 pi. So here now we can see actually we need to see proof fx. Fx equal to arc sin x plus arc cosine x. We need to prove what? We need to prove fx equal to 1/2 pi. 1/2 pi, yeah. So from we can use the constant difference theorem. We just need to see what? The f prime equal to 0. Yeah. If f prime equal to 0, of course f is a constant. Yeah. So we need to show that f prime equal to 0. So f prime equal to what? So f prime x equal to arc sin x prime plus arc cosine x prime. Yeah, arc sin prime is what? Arc sin prime is minus 1 by the square root of 1 minus x squared. Yeah? Although here is plus. Arc cosine here is what? Arc cosine here is plus. Here is minus 1 by the square root 1 minus x squared. Yeah? So now we can see here is plus, here is minus, they are the same. So equal to 0. Yeah? So equal to 0. So equal to 0, so f prime equal to 0. So here means what? Here means f, of course, here x is, for any x belongs to minus 1 to 1. So here means what? Here means fx is a constant c, yeah? Is a constant c, so for any x belongs to minus 1 to 1, yeah? So here this is by the constant difference. By the constant difference theorem. By the constant difference theorem, okay? So now we need to determine the c, okay? We need to determine the c, okay? So we can find what f0 equal to what? F0 actually is arc sin 0, yeah? Is arc sin 0 plus arc cosine 0. Arc cosine 0. Arc sin 0. So arc sin 0 for this here, okay? For arc sin 0 actually is what? Arc sin 0, okay? Here is alpha, here is beta, okay? So here means sin alpha equal to 0, okay? Sin alpha equal to 0. Alpha in what? Alpha in 0 to 1/2 pi, okay? 0 to 1/2 pi. So sin alpha equal to 0. Alpha belongs to this interval. So alpha equal to what? Sin what equal to 0 on this interval? Sin what equal to 0 on this interval? From 0 to 1/2 pi on this interval. Sin what equal to 0? Sin 0, so alpha equal to 0, okay? Alpha equal to 0, so here this is 0, is 0 plus, so here arc cosine 0 equal to beta, so actually is cosine beta equal to 0, beta in this interval, in 0 to 1/2 pi. So here, cosine beta equal to 0, okay? Cosine beta equal to 0, so beta in this interval. So cosine what equal to 0? 1/2 pi, yeah? So here is 1/2 pi. So 0 plus 1/2 pi, so it's 1/2 pi. So here means f0 equal to 1/2 pi, f is a constant, so means what? Means the constant is 1/2 pi, okay? So here we have what? Here we have the constant is 1/2 pi. 1/2 pi, okay? So from here we have what? So from here we have fx is a constant, and the constant is 1/2 pi. So the result actually we have arc sin x plus arc cosine x equal to 1/2 pi for any x. For any x belongs to 1 minus 1 to 1, okay? Minus 1 to 1. So this is the end of this chapter, okay? This is the end of this chapter. And now I say that I will give an examination at the end of each chapter, okay? So now for here, for chapter 5, okay? For chapter 5, the examination is at the last Thursday, okay? Last Thursday. Thursday you are free, yeah? No, Thursday afternoon. Yes, Thursday afternoon. So here is no. Last Thursday here is no. Let me see. October, okay. October 23, okay. October 23, no. 22, okay. October 22, okay. October 22 from 9 p.m. 7 p.m. to 9 p.m. Okay. From 9 p.m. to 7 p.m. to 9 p.m. On this classroom, okay. On this classroom. From 9 p.m. to 7 p.m. to 9 p.m. Okay. On this classroom. Okay, last Thursday, okay? Last Thursday. Last Thursday night, okay? Last Thursday night. So, from 9 p.m. to 7 p.m. to 9 p.m. On this classroom, okay? On this classroom.
Chapter 5, right?
Yeah?
Chapter 5.
Chapter 5. No. What?
Examination 2.
Yeah, just chapter 5, yeah. Just chapter 5, okay? And the answer time, so I know your Thursday is free, yeah? Thursday afternoon is free, yeah?
Yeah.
So the answer question, okay? So the answer question time is the answer question time is also on Thursday, okay? Answer question time, okay? Answer question time is Thursday. Thursday night, okay? Thursday night, Thursday afternoon, okay? Thursday afternoon from 3 p.m. to 6 p.m. Okay? From 6 p.m. to 3 p.m. to 6 p.m. Okay? Thursday afternoon and for Tuesday afternoon. Okay?
We have class.
Tuesday you have class.
Yeah.
Thursday you have class.
Here at 4 p.m.
This time you have class.
Yeah, 4 p.m. After 4 p.m. we have free.
7 p.m. to 9 p.m. Okay?
Yeah, but
What is it? But I don't know. It's very
Wait, okay?
okay.
But isn't that the same kind of attack?
The last time is I said that Wednesday, but some students tell me that Wednesday you have class, so you are not free. So I changed the time. Okay.
Okay. That's good.
Okay.
Yeah.
And this week, okay, this week, because this week I will be out. I will go to another city at this time. So this week, okay, just this week, okay, just this week, the answer question, okay, answer question time is Tuesday, okay. Tuesday afternoon. Tuesday afternoon. From 3 p.m. to 6 p.m.
Last year.
Tomorrow.
Last year, 6 p.m.
You have class.
Yes, last day, 6 p.m.
So this week.
Friday last day.
Friday.
Yeah. Friday, 7 p.m. to 9 p.m.
When are you coming back on?
Friday, okay. Friday, okay. Friday night, okay, from 7 p.m. to 9 p.m. Is okay?
Yes, sir.
This week, okay, just this week, okay, just this week, Friday night, from 7 p.m. to 9 p.m. So it's in my office, okay, this building 623, okay, 623. So here this is for this week, okay, for this week. Now we go to the new chapter, okay, we go to the new chapter. Now we see the chapter 6. The chapter 6. What? Huh? Yeah, just for chapter 5. So the exam just for the chapter 5.
No, last is chapter 5. Chapter 5.
Yeah, just chapter 5. Okay?
Yeah. Yes, no. But
In my study, okay, we have two important parts. The first important part is the deductive, okay. The second important part is the integration, okay. Integration. So now first we see introduction of the area problem, okay. Area problem. For example, for square for the here is a square, okay, is a square. The length is A, okay, the length is A. The length is A, so what's the square formula? The square A is equal to a square, yeah?
Yeah.
A square, yeah? So this is the formula, this is the formula of the area of square. So the second now we can see a rectangle. Rectangle, so here. So here we learn the length. Okay, the length is A, the length is A, the y is B, okay? The y is B. So what's the formula of the area of rectangle? Rectangle A
AB.
equal to A times B, yeah?
Yeah.
A times B. So this is the formula of the area of rectangle, okay? The third is the trapezoid. Trapezoid here. For example, here. So now for here a trapezoid, okay, for a trapezoid, so A is the upper bottom, okay, the upper bottom, so the B is the lower bottom, okay, H is the height, So what's the formula of the area?
Half H A plus.
A equal to 1/2 times A plus B
H.
times H, yeah? Times H. So this is for the upper bottom part, for the trapezoid. And now for the triangle, okay? For the triangle. For the triangle, okay? For the triangle here is for example, triangle A, B, C, okay? A, B, C. So here, so this here is A, here is B, here is C. Okay, here capital A, capital B, capital C, okay? So and then the height, here is H, here is H. So the area, okay. For the triangle, actually we have three formula, okay. The first formula A equal to 1/2 A times H, yeah. This is A is the base, H is the height, okay. H is the height. So 1/2 A times H. This is the first, okay. The second is what? So here, for example, for this angle, okay, for this angle we let it beta, okay, we let it beta. So actually here is also equal to what? H actually equal to C times sin beta, yeah. H, this H, okay, this H. Here is H actually equal to C times sin beta, yeah. So we replace H. We replace H by C sin beta, so equal to 1/2 A times C sin beta, okay? So this is the second formula, okay? Actually, we have the third formula. The third formula is what? Is equal to the square root of P times P minus A, P minus B, P minus B, P minus C, okay? P minus B, P minus C. So here P is what? P is 1/2 A plus B plus C, okay? So this is the third formula, okay? The third formula. So P is 1/2 A plus B plus C. So here means actually is 1/2 of the perimeter, okay? 1/2 of the perimeter. So the area equal to the square root of P times P minus A times P minus B times P minus C, okay? Times P minus C. So this is the area of some graph, okay, of some graph. But now if here for this function, okay, for if I give you a function, for example, for this, here is x, here is the origin, here is the y. So I give you a function y. This here is a graph, okay? Here is y equal to x squared. Here is 1, okay? Here is 0. So I have a question. So this part, okay? So what's the area of this part? So what's the area? So here this is the curve. This curve is given by a function y equal to x squared. Y equal to x squared. Here is the so here is the closed interval from 0 to 1. Okay. So now we have a question. What's the area of this part? What's the area of this part? So in general, okay, for another function here is not y equal to x squared, it's y equal to fx. Y equal to fx. Fx is a continuous and non-negative function. For example, for this function, okay, for this function, here is a function, here is a, here is b, here is b. So this function we know y equal to fx. Y equal to fx. Fx is continuous and non-negative. So we have a question. What about how to compute the area of this part? How to compute the area of this part? So this means the area problem. Okay, the area problem. So the area problem is what? So the area problem is give a function f. Give a function f. The function is continuous. The function is continuous. The function is continuous and non-negative. And non-negative on an interval. On an interval AB. So now we need to find the area, okay? Find the area between the graph. Between the graph of f and the interval AB on x axis. Okay, now, so what's the area problem? The area problem is I give you a function. The function is low. Okay, it's continuous and non-negative on a closed interval AB. Now we need to find the area between the graph of f, and the interval AB on x-axis. Actually, it's this part. Okay. So how to find the area of this part? We will introduce two methods. Okay. We will introduce two methods next class. So have a brief 10 minutes.
Nah, por eso con ellos, pero no. rejected. হ্যাঁ মঙ্গলবার সপ্তাহে
Date of death.
আগে ওই যে
How can you forget your date of death?
We introduce two methods. Okay, we introduce two methods. The first method, okay, the first method is the area problem, okay? Give a function f is continuous and non-negative, on an interval AB. Find the area between the graph f and the interval AB on the x-axis, okay? So here we introduce two methods. The first method is means the rectangle method, okay? The rectangle method. So the rectangle method. So the first method, okay? So the first method means the rectangle method. The rectangle method here, this method actually we use idea. Okay, the idea is execution method. Okay, so for example, we need to find the area of a circle. Find the area of a circle. So how to find the area of a circle? Here is a circle. Here is a circle. Okay. Here the circle. The radius is 1. Okay. The radius is 1. So how to find the circle? The area of the circle. So we use the execution method. Execution idea. Okay. So here first, the idea is we inscribe. We inscribe regular polygon. We inscribe a regular polygon in the circle. Okay, in the circle. And now for first here, for example, we inscribe a triangle. Okay, we inscribe a triangle on the circle, and now we can compute the area of the triangle. Yeah, we compute the area of the triangle. So we use the triangle. The area of the triangle is we use H3 to denote it. Okay, H3 denote the triangle. Okay, the area of the triangle. The triangle is inscribed inside the circle. Okay, inside the circle. So this is the area of the triangle. And now we increase the number of the sides. Okay, the number of the sides. So here this is a circle. This is a circle. Now we inscribe a square. We inscribe a square. In the circle. Okay. So here we use A4. We use A4 to denote the area of the square. Okay. The area of the square. And actually we can compute it. Okay. Actually we can compute it. And go on. We inscribe we describe a five frame size of regular polygon. Okay, so here, so we can compute the area. The area here is A5. We can do it again. Okay, do it again. So just like this. Okay, so just like this here. Here first is a triangle. Here is a triangle. We can compute the area. The second, we describe a square inside the circle. Okay, inside the circle, and then five sides of five regular polygon. Okay, and 6 regular polygon will go on. Okay, go on. So now we can see a clear that when the at the number, okay, at the number of size, as the number of size increase, as the number of size increase, the area of polygon, okay, the area of polygon become better and better, better and better, better and better approximation, okay, approximation of the exact area of the circle, okay, of the circle. So here means that as the number of the size increase, the area of the polygons becomes better and better approximation of the exact area, okay. So here we can see here n is the number of the size. Here an means the area of the polygon, okay. So a 100 when the number of size equal to 100, okay. The an actually is the area of the regular polygon, okay. So it's 3.1395 and go on, okay. And now we increase the n, so we can see that when n increase, okay, when n increase, an get better and better approximation of the area of the circle, okay. So we have a conclusion. The conclusion means that an, okay, when n go to plus infinity, okay, when n go to plus infinity, an actually we are the limit actually is the area of the circle, okay. A is the area of the circle. An is the area of the circle. So here this is the execution, okay, execution idea. So we now it's the same, okay. So this is the idea. Now for this problem, okay, so we use the execution idea, okay. So how to find the area of this part? How to find the area of this part? So actually it's the same, okay. So here, the first we use the execution idea. So it's the same, okay. Here we can divide, okay. We can divide the interval. We can divide the interval AB into for example into 3 parts, okay. Into 3 equal sub intervals. So we divide, okay. We divide AB into n, okay, into n equal sub intervals. So here means what? Here means, for example, we we divided AB into three equal subintervals here. Here the 3. So here, so actually, so here, now, this part, okay, this part, we use this area, okay, this area actually we use A, okay, in A. So here, first here, this part, actually A equal to, here this part we use is A1, this part we use to A2, this part we use A3, yeah? So it's easy to see that A actually equal to A1 plus A2 plus A3, yeah? Yeah? So here the first we divided the closed interval into three intervals or three equal subintervals, okay? And then we can see A actually equal to A plus A equal to A1 plus A2 plus A3. So now for here, for A1, okay, for A1 actually we can use a rectangle to approximate it. For example, we can take the endpoint. We can use this rectangle, okay? This rectangle. We can use this rectangle's area to approximate A1, okay? To approximate A1. So this rectangle here, this part actually is here. Here, this is the length. This is the y. Okay, the y actually is what? Is the function value at the left point. Okay, at the left point. So here now we use this rectangle. Okay, this area. The area of this rectangle to approximate the area of A1. Okay, and now we use what? We use the second here. We use the second here. We use the area of the rectangle to approximate the area of A2. Okay, A2. So similarly, okay. So similarly, we use the third rectangle. The third rectangle here. The third rectangle here. This part. Okay, this part. We use this rectangle, the area of this rectangle to approximate A3, okay? To approximate A3. So here A1 we use the first S1. S1 is the area of the first rectangle, okay? And so A1 we use S1 to approximate A1, okay? And S2 is the area of the second rectangle. Okay, the second rectangle. We use S1 to approximate A2. Okay, and we use S3. S3 is the area of the third rectangle. Okay, the third rectangle. We use S3 to approximate A3. Okay. So here we can see we can use the sum of S1, S2, S3 to approximate A1, A2, A3. So it approximates equal to, okay? So we can do it here is divided into three equal subintervals. Okay, of course we can divide AB into 4 equal subintervals, 5 equal subintervals. Okay, so here now let's see here. For example, here the first, the second, the third, the fourth. So we use here is the 5 divided AB into 5 subintervals. Okay, and here we have more. Okay, here we have more. Okay, so now we have this idea we have two steps. The first step is divided the interval AB into n equal subintervals. Okay, into n equal subintervals. And over each subinterval, okay? Over each subinterval construct a rectangle that extends from the x-axis to any point, okay? To any point on the curve y equal to fx. So here means that we can any point, okay? Any point we can use the left point or the right point or any point on this subinterval, okay? So here, to any point on the curve y equal to fx, that is above the subinterval, okay? And the particular points does not matter, okay? Does not matter. It can be above the center, above an endpoint, or above any other point in the subinterval, okay? So for example, for this finger, okay, for this finger we use the center, okay, we use the center. So here this is the first step. The second step is for each end, the total area of the rectangles can be viewed as an approximation to the exact area under the curve over the interval AB, okay? So the total area of the rectangles can be viewed as an approximation to the exact area under the curve over the interval AB, okay? Moreover, it's evident intuitively that as n increase, this approximation will get better and better, and will approach the exact area as a limit. That is, if A belongs to the exact area under the curve, and An belongs to the approximation to A use n rectangles, then we have this conclusion, okay? The limit n approaches plus infinity, n approaches A, okay? An approaches A. So this is the first method, okay? The first method. So in this method, we just use more and more rectangles, okay? More and more small rectangles to approximate the area, okay? The area. So I give an example of this function, of this method. For example, for this function, okay? For this function, here, now we need to find here is x, here is y, here is the origin. So here is the curve is y equal to x squared. Okay, y equal to x squared. So on the interval is 0 to 1. Okay, it's 0 to 1. 0 to 1. Okay. So now we need to compute the area under the curve y equal to x squared, and above the interval from 0 to 1. Okay. Now we need to compute the area. So the first, okay. So the first here. The first we need to divide the 0 to 1 to n equal subintervals. Okay. So 0 to 1 here is we need to find n intervals. Okay. N subintervals. So here, so this point actually is what? Is 0, here is 1 by n, here is 2 by n, yeah? Here is 3 by n, here is 4 by n. Go on, yeah? So here, the first rectangle, okay? So the first rectangle, we say that we can choose the left endpoint, okay? So we can use here the first rectangle, the first rectangle here, we choose the left endpoint, okay? The left endpoint, so here means what? Here means The first rectangle actually here, because here is 0. If 0 is 0, so the first rectangle is, the length is 1 by n. The width is 0. Okay, so this is the first rectangle. The second rectangle, we use the left endpoint. So the second rectangle, the length is also, the length here is 1 by n, yeah? So now, what's the width? The width actually here is, this is the second rectangle. So what's this part? This part actually is the function value at the 1 by n, yeah? 1 by n. So here we can see an equal to what? The first, okay? The first rectangle, the length is 1 by n. And the width is, we say that we use the left endpoint. So here is 0 square, yeah? So this is the area of the first rectangle. So the second rectangle, so here, the length is also 1 by n, okay? The length is also 1 by n. And the width is what? The width is this part. This part, so here is the function value at the point 1 by n, yeah? So the width actually is 1 by n squared, yeah? Because here, the function value or the curve is y equal to x squared, where x is equal to 1 by n, y equal to 1 by n squared, yeah? So here, this width is 1 by n squared. So this is the area of the second rectangle. So this is the area of the second rectangle. Now for the third rectangle here, the length is also 1 by n, okay? The length is also 1 by n. And the width is what? The width actually is the function value at the point 2 by n, yeah? So 2 by n, so here is 2 by n squared, yeah? So this is the area of the third rectangle, okay? So we can go on, okay? We can go on. So here the fourth, here is also what? Here is also 1 by n. The length is also 1 by n, and the width is what? It's the function value at the point 3 by n, yeah? So 3 by n here is times 3 by n squared, yeah? This is the area of the fourth rectangle, yeah? So we can go on, okay? We can go on now for the last one here actually, for the last one, this point, actually it should be n minus 1 by n, yeah? So here the last one rectangle is also here, the length is also 1 by n. And the width here is the function value at the point n minus 1 by n, okay? So it's n minus 1 by n squared, yeah? So this is the total area of the n rectangle, okay? The total area of the n rectangle, so we can take out 1 by n, okay? We can take out 1 by n, so it equal to what? So it equal to 1 by n. Here is 0 square, 0 square is 0. So here is 1 by n square. So here is 1 square divided by n square plus 2 square by n square, yeah? So go on. The last one is what? Is n square, here is n minus 1 square, yeah? Yeah, it's like this, yeah? So now actually we can take n square out. We can take n square out, so actually equal to what? Equal to 1 by n cubed. Here is 1 square plus 2 square plus n minus 1 square. So do you know the formula of 1 square plus 2 n square? So actually we have the formula, okay? 1 square plus 2 square plus n square equal to what? 1 square plus 2 square plus 2n square. equal to what? Actually, we have a formula, okay? We have a formula here is 6, here is n minus 1, 2n minus 1, okay? 2n minus 1. So this is the formula, okay? This is the formula. n times n plus 1 times 2n plus 1, okay? Divided by 6. So here we can use the formula, okay? Replace the n here, replace the n by n minus 1. So here actually this is equal to what? This is equal to, here is n cubed times 6. Replace n by n minus 1 in that formula. So here is n minus 1 plus 1, okay? N minus 1 plus 1, so here is what? Here is n, yeah? And 2 times n minus 1 plus 1, yeah? So here is 2n minus 1, yeah? So times 2n minus 1, yeah? So this is the result, okay? This is the result. So here, actually we can, here equal to what? Here equal to 6n cubed, okay? 6n cubed, here is n times n minus 1, 2n minus 1, okay? 2n minus 1. So here for this one, okay? For this one we can, here is n times n minus 1, here is n squared minus n, okay? So here is, here is n times n minus 1. So here is n cubed, we can cancel 1, okay? We can cancel 1, and so here is n squared, yeah? Yeah?
Laushi, please just leave because by the time we come and copy there, we will not.
What? So here, from here, can you understand here?
Yes, Laushi.
Here?
I say like then when you cancel, when I will come and copy, I will not know because we already did it.
Here is n.
Yes.
Here is 6n cubed, yeah?
Yes. And then just say equal, then proceed.
So here we can cancel 1n, yeah? Cancel 1n, so here is n minus 1, here is 2n minus 1 divided 6n squared, yeah?
Can you just start explaining from that equation 1 over n3, the last one there?
Yeah?
Yes, then you continue with the equation.
Now we can see 1 squared plus 2 squared. We have a formula, okay? 1 squared plus 2 squared plus n squared. Okay, equal to 6 n times n minus 1 plus 1, 2n plus 1 divided by 6. So now from here we have what? We have 1 square plus 2 square plus n minus 1 square. This is equal to what? This is equal to, here is also 6. We replace n by n minus 1 in this formula. Okay? So here the first is n minus 1. The second is n minus 1 plus 1. So here is n. Here is 2 times n minus 1 plus 1. Yeah? So here is 2n minus 1. So this is yeah? We use this formula here. So we can get this answer. This answer. Okay, so here we cancel 1n. So here is n minus 1 times 2n minus 1 divided by 6n squared. So here we can see, we can open the bracket, okay? So here is we can open it. So here is what? Here is 2n squared minus 3n plus 1 divided by 6n squared. Yeah? 2n squared minus 3n plus 1. divided by 6n squared. So when n go to plus infinity, this go to what? This which is what? So 0. Here is n squared, here is n squared.
One.
So we divided n squared on both sides. Yeah. So here equal to what? Here equal to we divided n squared on both sides. So here is 2 minus 3 over n plus 1 by n squared. Yeah. Here is 6. Yeah. So when n go to infinity, so this here go to what? Go to 2. Yeah. 2 over 6. So here for 2 is 1 by 3. Yeah. 1 by 3. So here is what? When n go to infinity, okay, the total of the n rectangle, the total area of the n rectangle go to 1 over 3. So this area actually is 1 by 3. Okay. This area actually is 1 by 3. So now, okay, in this here just we use the left endpoint, okay, the left endpoint. Actually, we can take the right endpoint, okay. Okay, now we can see if we take the right. Now let's see if we take the right endpoint, okay? So here, now we here, okay? Here is y equal to x squared. Here is y equal to x squared. And the first is all the same. Okay, we divided the interval. Okay, the closed interval into n. So divided the closed interval 0 to 1 into n sub n equal sub interval. Okay. So here this is the first, the second, the third. Okay. The fourth go on like this. Okay. So here the first this point is 1 by n. The second is 2 by n. The third is 3 by n. This is 4 by n. The last one is n minus 1 by n. Okay. So now we take the right endpoint. Okay, the right endpoint. So we can see here the first rectangle is what? The first rectangle is the length is 1 by n. The y actually is we just take the right endpoint. So the right endpoint is here. Yeah. So here is this is the first rectangle. Okay. This is the first rectangle. So here we have the first, here an equal to the first rectangle, the length is 1 by n. The length is 1 by n. Okay? The y is what? The y is here, the function value at the point 1 by n. Yeah? So here is 1 by n squared. Yeah? So this is the area of the first rectangle. Okay, the second rectangle here, here is also the length is 1 by n. Okay, and the y actually we take the right endpoint. So we take it here. So actually this is the second This is the second rectangle, yeah? The second rectangle, so here the length is 1 by n, and the width is 2 by n, okay? 2 by n square. 2 by n square. This is the second, okay? The area of the second rectangle. So the third rectangle here is also the length is 1 by n, and the width actually is this part. Yeah, this part. So the width actually is the function value and the 3 by n, okay? 3 by n, 3 by n, the function value and the 3 by n. So here is plus 1 by n times 3 by n square, okay? So this is the area of the third rectangle, okay? Go on. Now, the last one here is the length is also 1 by n, okay? And the width, we just take the what? We take the right end point. So here, actually, we use this rectangle, okay? This rectangle. So here is actually this, the function value and the point 1. So here is 1 square. 1 we can write it by n by n, okay? 1 equal to n by n. So here is n by n square. N by n square. So this is the total area of the n rectangle, okay? Rectangle. So here equal to what? We take out 1 by n. We take out 1 by n, so it's 1 square by n square plus 2 square by n square plus 3 square by n square plus n square by n square, okay? So we take out n square. We take out n square, so it's equal to 1 by n cubed. Is 1 square plus 2 square plus n square, okay? Plus n square. So here equal to what? So here equal to, it's the same, okay? Here is n cubed. So 1 square plus 2 square plus n square is equal to 6. Here is n times n plus 1, 2n plus 1, okay? So here we have this result. This result is the same, okay? Here is n, here is n cubed. So we cancel 1, okay? So we cancel 1, so here is 6n squared. Here is the denominator, okay? Denominator, the numerator is what? Is n plus 1 times 2n plus 1, yeah? So here n, so here we open it. So we open it, so it's equal to what? 2n squared. 2n squared plus, here is n, here is 2n, so 3n plus 1, okay? Plus 1 divided by n squared. So when n goes to infinity, so this formula goes to what? It's the same, okay? We can divide it n squared on both sides. So here is what? So here equal to, 2 plus 6 or 3 by n plus 1 by n squared. Here is 6. Then when n go to infinity, this part go to 0, this part go to 0. So actually this go to what? This go to 2 by 6 equal to 1 by 3. Yeah. When n go to infinity. So here, so now we can see if we take the left endpoint, so the area is 1 by 3. If we take the right endpoint, the area is also 1 by 3. Okay?
Yeah.
So here means what? So here means this sentence. Okay? So now the particular point does not matter. Okay? You take the left. Okay, you take the right, okay. You take the center, okay, or you take any point in the sub-interval is okay. So here, this is the first, okay. So this is the first method. to find the area, okay? To find the area. Now actually, so now we introduce the second method, okay? So the second method actually means the second method, okay? So the second method here is so the second method so the first method, okay, is tedious, okay, tedious. But now for the second method means that, wait a moment. Now we introduce the second method, okay? The second method means the any derivative method, okay? The any derivative. The antiderivative method. The antiderivative method. So here is the same. Okay, for now here is the same. Okay, we give a closed interval AB, and here is a function y fx. This function is continuous and non-negative. Okay, and non-negative. So the function is continuous and non-negative. Okay. So here now we denote the area. We denote the area. We denote the area under the curve, okay, under the curve and above the closed interval. So we denote it by A, okay, we denote it by A. So now, of course, this A, if we change it, if we fix the A, okay, if we fix the left endpoint A, okay. If we fix the left, fix the A, okay? So actually the A actually is independent. A is dependent on B, yeah? Of course here, A, okay? If we B here and B here, actually if B here, the area is this part. If B is at here, so the area is this part, yeah? So here means what? Here means the area A is dependent on B. So here so A is dependent on B, so actually A is a function of B, okay? A is a function of B. So here now we use X. Here we use X to denote the right endpoint. Okay. So the area actually is dependent on X. So here is AX. Okay. AX. So here means if we fix the A, we fix the A and changeable, okay? Changeable right endpoint, okay? Right endpoint X. So now we give a curve. We give a curve y equal to fx. Y equal to fx. Now let we use ax to denote. We use ax to denote the area. The area under the curve. Under the curve, y equal to fx, and over the interval, ax, okay, ax. So here means what? Here means fix the left endpoint A, and the right endpoint X is changeable. Okay, it's changeable. So here we use AX to denote the area, under the curve, and above the closed interval. So now we have a question: what's the relationship between AX and the function fx? So what's the relationship between AX and so now we have a question. What's the relationship between AX and fx? So what's the relationship between AX and fx? So now we have this question, okay? AX denotes the area, fx is the curve, okay? Is a curve. So now, what's the relationship between AX and fx? Now. So first we give some example, and we find the relationship of between AX and fx from the example. Okay, from the example. So the first example is now. The first example is fx is a constant function 2. Okay, is a constant function 2, and the closed interval AX. The closed interval AX is -1 to x. Okay, here means -1 to x. Okay, so fx is a constant. So now we can plot it. Here is x. Here is y, so the closed interval is -1 to x. So here is -1, here is x. So in this closed interval, okay, and the function is fx equal to 2. So here is 2. So here is a constant. So here is y equal to fx. Y equal to fx. Fx equal to 2, so y equal to 2. Okay. So the area actually is what? So the area actually is this part. Yeah. This part. This is AX. Yeah. So it's evident that this part actually is what? Is a rectangle. Yeah. The rectangle. So the length is what? The length is this part. Yeah. So this part is what? What's the length? The left point is -1, the right point is x. So here the length is what? X minus -1. So it's x plus 1, yeah? So here is x plus 1. So what's the y? 2, yeah? So here is 2, here is x plus 1. So here we have what? Ax equal to x plus 1 times 2, yeah? So the result actually is 2x plus 2, yeah? So ax, so now we can see ax equal to 2x plus 2. And fx equal to what? Equal to 2, yeah? So what's the relationship between these two functions? What's the relationship between ax and fx? Ax equal to 2x plus 2. Fx equal to 2. So what's the relationship between these two functions?
fx is derivative of a.
Yes, fx.
Yeah. So a prime equal to f, yeah? So we have what? So from this example, we can see a prime equal to f, yeah? A prime equal to f. So this is the first example, okay? Now we give the second example. The second example is fx equal to x plus 1, okay? Fx equal to x plus 1, the closed interval is minus 1 to x. Okay, minus 1 to x. So now we can see x plus 1, we can plot the graph. We can plot the graph on this interval, so here actually is like this. Here is minus 1. Here is x. Here is x, okay? And the function is fx equal to x plus 1. So when x equal to minus 1, when x equal to minus 1, f minus 1 equal to what? F minus 1 equal to minus 1 plus 1 equal to 0, yeah? So here is a function like this. Yeah? So here is y equal to fx. So the area actually is this part. Of course, it's a what? It's a triangle, yeah? It's a triangle. So here we can see the base here is what? The base here is what? Here is minus 1, here is x. So the base is x minus 1. So x plus 1, yeah? So the height is what? The height actually is the function value at the x, yeah? So here the function value here, this is what? This height is what? Is the function value at the x. So the function value at x is what? X plus 1, yeah? So we can see ax equal to what? Ax equal to 1/2 times the base. The base is x plus 1, yeah? And the length, the height is what? X plus 1, yeah? So it's x plus 1. So the result actually is 1/2 x plus 1 squared, yeah? Ax equal to 1/2 x plus 1 squared, and the fx equal to what? Fx equal to x plus 1. So what's the relationship between these two functions?
Fx equal to ax derivative.
Yeah. So we can see a prime actually equal to f, yeah? So here we can see what? A prime equal to fx. So now, from the second example, they ask that the function value of the derivative of x equal to fx. Okay, this is the second example. Now we give the third example. So the third example is so third example is fx equal to what? Equal to 2x plus 3. Okay, 2x plus 3 and the closed interval is minus 1 to x. Okay, minus 1 to x. So here now we can plot the graph. Okay, we can plot the graph here. Here is x. Here is minus 1, here is x. So we can see f minus 1 equal to what? F minus 1 equal to 2 times minus 1 plus 3, yeah? So it's what? It's 1, yeah? So here is 1, and this function is passed through this point. And the slope is what? The slope is 2, yeah? So actually it's like this. Actually it's like this. So here the area actually is this part. Is this part, yeah? So of course, the AX, okay? The AX actually is the area of a trapdoor, yeah? A trapdoor, so here, this part, this, the up bottom, here is 1, yeah? So this part is what? This part is the function value at the point x, yeah? The function value at the point x is 2x plus 3, so here is 2x plus 3, yeah? And what's the height? The height here is x plus 1, yeah? So here we have ax equal to 1/2 the up bottom. Up bottom is 1 plus the lower bottom. Here is 2x plus 3, yeah? Times what? Times x plus 1, yeah? Times x plus 1. So here is what? So here is 1/2. Here is 2x plus 4. 2x plus 4 times x plus 1, yeah? Here, so we can take out 2 out, and 2 and 1/2 cancel. So here is x plus 2 times x plus 1, yeah? So we can open it. So x squared plus 3x plus 3x plus 2, yeah? So ax equal to x squared plus 3x plus 2. So fx equal to 2x plus 3. So what's the relationship? So it's easy to see a prime equal to what? So a prime, okay? A prime equal to 2x plus 3, yeah? 2x plus 3 is what? Is fx, yeah? It's fx. So here means what? A prime equal to f. So from these 3 examples, okay? From these 3 examples, tell us that the relationship between ax and fx is the derivative of a equal to f. So here means what? Here means if I give you the curve, okay? If I give you the curve, if you can find a function, that function derivative equal to f, then you can find the area, okay? So here, this is the second method, okay? This is the second method. So now, this is the second method. We give an example. So now we can answer the question, okay? We can answer the question ax prime equal to fx, okay? Ax prime equal to fx. So now we give an example. To use this anti-derivative method to find the area. So here we give an example. Use the anti-derivative method to find the area. To find the area under the graph. Under the graph of y equal to x squared over the interval over the interval 0 to 1, okay? Actually, okay? We use the rectangle method to find the area. We know the area is 1 by 3, yeah? It's 1 by 3. Now we use another method, okay? The anti-derivative method to find the area. Okay, so here now we can see we can plot the graph. Okay, plot the graph. Here is x, here is y. Here is y equal to x squared. Here is 1, here is 0. So now we can see what? The area. So here, now we fix the left point. The left point is 0. The right point is x. So we use ax. We use ax to denote the area. So here now we can see. So now we can see here the area x. What's the relationship between ax and x squared? So here we know a prime equal to x squared. Yeah.
Yes.
Now we use this conclusion. Yeah. We use this conclusion. We know a prime equal to x squared. Yeah. So what function derivative equal to x squared? What function? Okay. What function square?